So to rectify this AC into DC, the circuit consists most common or main important thing is a PN junction diode. During the negative half cycle or the second half cycle, this A becomes negative and B acts as positive. When the diode D1 is in forward bias condition, it helps us in conduction, and diode D2 will be in reverse bias condition, which do not conduct. Hello all, welcome to session 2 of chapter 14 Semiconductors and Electronics. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have studied about the electronic circuits, a PN junction diode, and also the difference between the vacuum tubes and diode. What are the advantages of diode over the vacuum tubes? Also many more basic things regarding semiconductors and electronics. In this session, we shall study about the next version, that is rectifier. Another important concept, that is rectifier. What is a rectifier? So the rectifier is a device that converts alternating current, that is AC, into DC. Or we can say that it converts the bidirectional current into unidirectional current. So the circuit which is used to convert the AC into DC is called as rectifier. And the process of conversion of AC into DC is called as rectification. The process is called rectification. The device used to rectify this is called as rectifier. So what are the types of rectifiers? We have two types of rectifiers. One is half wave rectifier. The other one is full wave rectifier. So what is the difference between half wave rectifier and full wave rectifier? As the name suggests, half of the AC cycle will be converted into DC in case of half wave rectifier, and full AC cycle will be converted into DC in case of full wave rectifier. So we use different circuit diagrams for rectification in case of half wave rectifier and also in case of full wave rectifier. So to rectify this AC into DC, the circuit consists most common or main important thing is a PN junction diode. So how the action of PN junction diode helps in rectification process, we shall learn. So half wave rectifier circuit consists of a primary transformer where the AC input is given, and a secondary transformer which is connected with a diode. I'll call it as D1. This is the P side and this is the N side. So now the output can be calculated across resistance RL. So here we can find out the DC output, which means whatever the signal we are sending here, it's an AC signal. It consists of a primary circuit or primary transformer and a secondary transformer. So a secondary transformer consists of a PN junction diode, and the resistance RL is connected to the diode in the secondary transformer, where we are going to find the output voltage or the converted DC signal. So we have 2 points, important points here. I call it as A and B since it is the input what we are sending is an AC signal. So the diode has 2 points, that is A and B. So as I said, we have considered a transformer. So after this rectification process, we get a output signal. Say for example, I am sending an input AC signal. So this is my input signal. After rectification, since it is a half wave rectifier, only half of the AC cycle, that is the positive cycle of the AC signal, will be converted into DC signal, and hence we get output only during the positive half cycle, not during the negative half cycle. So this is the circuit for half wave rectifier, whereas the half wave rectifier is a device where we can get output only during one of the half cycles of AC signal, and hence the name half wave rectifier. Let us now study about the working of half wave rectifier. So what happens during the first half cycle? During one of the half cycle, this A acts as positive and B acts as negative. So when A is positive and B is negative, the diode is said to be in forward biased condition. So in the last session, we have studied that the diode helps in conduction only when it is in forward bias condition, but not in reverse bias condition. So when the diode is in forward bias condition during positive half cycle, say for example, this is my input, during the first half cycle, the diode conducts. Because of that, we will get an output. Because A acts as positive, which means the diode is in forward biased condition. During the negative half cycle or the second half cycle, this A becomes negative and B acts as positive, which means the diode is in reverse bias condition. So we know that the PN junction diode does not conduct when it is in reverse bias condition, and hence we do not get any output during the negative half cycle. Since B acts as positive, A acts as negative, diode is in reverse bias condition. Again, in the next cycle, A becomes positive, B becomes negative, and we do get output during the positive half cycle. So since the diode polarities reverses during negative half cycles, the diode will be in reverse bias condition, and hence there is no conduction. When there is no conduction, we do not get any output, and hence we get output only during positive half cycles, and only half of the cycle of AC signal will be converted into DC. That is the working of half wave rectifier. As we all know, rectifier means a device that converts AC into DC. Since it consists of only one diode, it can conduct only during forward bias condition, that is during positive half cycle. So whatever the output we get from this is unidirectional and it is always pulsating. So this is about half wave rectifier. Let's now understand the mechanism of full wave rectifier circuit. So let us now draw the circuit for full wave rectifier. Again, it consists of a primary transformer where the input AC signal will be sent, and it consists of a secondary transformer, but it consists of two diodes, that is D1 and D2. So this circuit is center tapped. So center tapped because the input signal will be divided in for two diodes as well. So it is grounded. So now the resistance RL is connected here, across which we are going to find the output. So this is circuit diagram for full wave rectifier. This is point A and this is point B. This is our primary transformer and this is the secondary one. This is the circuit for full wave rectifier. What is the basic difference between the half wave rectifier and the full wave rectifier? So it consists of a diodes, two diodes, that is D1 and D2. So here this is positive and negative, and this is also anode and this is cathode. So that's positive and negative. Whereas in half wave rectifier we had only one diode. In case of full wave rectifier we have two diodes. So that is the reason why we get output in both the cycles, because two diodes acts here. So what is the working? Before going to study about the working, I'll tell you about the output. How do we get the output? Say for example, this is input signal. So it's a sinusoidal waveform because we are sending alternating current, and the output we get is bidirectional current, that is converted DC signal. Since we use two diodes, we get output in both the cycles, whereas in half wave circuits or half wave rectifier circuits, we used to get output only during positive half cycles. So this is the output we can get from full wave rectifier. Then how do we get this? Because as we send the input AC signal through the primary transformer, so we know that during positive half cycle or during the first half cycle, this A acts as positive, B acts as negative, which means the diode D1 will be under forward bias condition. When the diode D1 is in forward bias condition, it helps in conduction, and diode D2 will be in reverse bias condition, which do not conduct. So whatever the output we get during positive half cycle is due to diode D1, which is working under forward bias condition. So during the next half cycle, what happens? A becomes negative and B becomes positive. So when B becomes positive, the D2 is in forward bias condition, where D1 is in reverse bias condition during the second half cycle. Since diode D2 is in forward bias condition, when this diode helps in conduction, or even this diode helps in conversion of AC into DC. Because of diode D2 in the second half cycle, we get output even in the negative half cycle of the input. Similarly, in the next half cycle, these polarities get reversed and diode D1 conducts, so we get then output, and in the next half cycle diode D2 conducts, because that will be in forward bias condition, we get output for again negative half cycle. So like this we get the total input of AC signal is converted into a complete DC signal during both the half cycles in case of full wave rectifier. Since we get output in both first and second or positive and negative half cycles, fully AC is converted into DC, and the device which helps us to convert the complete AC into DC is called as full wave rectifier. So as I told, this is due to D1 and this is due to D2. Like this it continues. So whatever the output we get, it is unidirectional. So the current across the resistor RL helps in getting the output. So we used to check output across the resistance RL, and the output we get is a converted DC signal. So not only a circuit diagram is important for rectifiers, it is also important to show the input and output signals, waveforms, like this even in the examination. That is very important. So don't forget to write circuit as well as the waveforms for full wave as well as half wave rectifier. So this is about the rectifiers, rectification, half and full wave rectifiers, and this ends the chapter Semiconductor Diode. Keep learning all of you. See you all in the next session. Thank you.